friends, this video is an introduction to ratios and proportions, and I would like you please to take some notes as if I were putting this up on the board in class. So let's start off with some definitions. So one of the most important definitions is what is a ratio? What do we mean when we talk about a ratio? And we use ratios all the time to compare two numbers. For example, I'm going to need 2 hamburger buns for 1 hamburger. So that is a ratio of 2 to 1. Or I could write it as 2:1, like this here. Or I could write it as a fraction of 2/1. I might have, that would be a part-to-part ratio because there's one part is the buns and one part is the hamburgers. I might have also a part-to-whole ratio. For example, I might say, in my bowl, my fruit bowl, I have 4 oranges for every 10 pieces of fruit that I have. So the oranges are part of the 10. So I might say that the ratio of oranges to fruit would be 4 to 10, and I could write it this way. Or I could write it with words, 4 to 10. Or I could write it as a fraction, 4 to 10. All of these ratios can be simplified, and you're used to simplifying them, particularly when they're written as fractions. And you could do that this way as well. Okay. A proportion is a special kind of, it's a comparison of 2 ratios where you know that both of the ratios are equal. So the example that I have here is if I have 3 wheels for 1 tricycle, then I would have to have 9 wheels for 3 tricycles. The order for ratios and proportions is really, really important. So the order that the words go in have to be the same order that the math goes in. So for example, if I say wheels first, the ratio of wheels, and then I say tricycles, so wheels to tricycles. If I say it in that order, then the math has to go in the same order. So the wheels means there's 3 wheels for every 1 tricycle. Here it's pretty simple because it wouldn't make any sense. You couldn't have 1 wheel for every 3 tricycles. That would not be a lot of fun. Okay. But no matter what the situation is, whatever word comes first, that corresponds to the number that comes first in the ratio. Whatever word comes second, that corresponds to the number that comes second. Okay. So with that in mind, here's 2 ways that we could write proportions. Now remember, these are proportions, so these are 2 ratios that are equal. So notice 2 to 3 is the same as, or is equal to, 8 to 12. And actually, I can think of that as being true because 2, if I did 2 times 4, I'd get 8. And if I did 3 times 4, I'd get 12. So those are equivalent ratios. Here's a fraction example. 3/5 is the same as 6/10. And I know that that's true because I could simplify 6/10 right back to 3/5. So these are equivalent ratios. One other thing that you need to know about ratios and proportions is that there are words for some of the parts inside of the proportion. So for example, the extremes of a proportion would be the outside ones, the first and the last. They're extreme. They're as far away as they can be from the middle, right? And so here, for this first example, the extremes are 2 and 12 because they're the outside of this example. The means are the 2 numbers that are closest to the middle. Means sometimes is also used to, for the word average, right? And average means sort of finding the middle of something. So the means of a proportion are the ones closest to the equal sign in the middle. It's a little bit harder to see when you move it into a fraction way to write it, but the extremes are still, we're going to read from top to bottom and then from top to bottom. So the extremes are still the first and the last, right? This 3 and this 10. And the means are the second and the third, so the ones sort of in the middle. Okay? Now, the reason that we care, let me highlight means in blue there. Okay, so the reason that we care about these extremes and means is because there's a really neat thing that happens when we compare the extremes and means of proportions. And I actually want you to look at these and see if you notice anything. Pause it if you want to take an extra moment. But see it. Look at the means and extremes and compare them. See if you notice any patterns before I move on. Okay, so now if we're ready to sort of talk about this, let's take a look at these means and extremes. So if I look at this first problem, the extremes are 2 and 12. And the means are 3 and 8. And if you haven't noticed yet, there's something going on with the product of these extremes and the product of the means. In other words, if I multiply the extremes together, if I multiply 2 times 12, those are my extremes for the first case. Oops, wrong color. If I multiply my extremes, 2 times 12, and then on the other side over here, I'm going to multiply my means, 3 times 8. Oh, maybe you've noticed it now. What do I get if I multiply 2 times 12? Yeah, that's right. I'm going to get 24. And if I multiply 3 times 8, I get 24. So the product of the extremes is equal to the product of the means. That's pretty cool. It works if I write it this way too, as a fraction. And actually, it's sort of one of the neat things about writing it as a fraction is you can kind of see, right, this cross pattern here, right? So if I were to say the extremes, the product of the extremes would be 3 times 10. I'm pretty sure it's going to be equal to the product of the means because that's what Kate just said. But let's see. Let's find out. So 3 times 10 is 30. Look at that. 30 is equal to 30. So the product of the extremes, again, the product of the extremes is the same as the product of the means. So that can come really handy because if somebody's going to say to you, hey, are these two fractions equivalent? You could go through all the trouble of trying to simplify both of the fractions, being like, oh, okay, well, what goes into 6? That also goes into 10. Okay, 2 goes into both of them, so I'm going to divide both of them by 2. So you could go through all of that work and prove that they're equivalent. But sometimes it's going to be a lot faster and a lot easier to just multiply and check. So for your next task, I'm going to ask you to spend just maybe 5 to 10 minutes on IXL practicing just identifying whether two fractions actually form a proportion, or maybe it's not a proportion, maybe they're not equivalent, okay? And the fastest way to do that is to multiply your extremes and means and see if you get the same number, okay? So go ahead and look at that next. Thank you so much.